I will start by a simple question. Like, what is machine learning? How many of you have heard of machine learning? By show of hands, how many of you have heard of machine learning? Let me see. By show, yeah, Peter. What about the rest? Does it mean the rest you have never heard of machine learning? I think I mentioned that yesterday and even the day before yesterday. But we can just begin by asking ourselves what is machine learning, and we can start by maybe understanding how human beings learn. Uh, so today we are saying in short that in the real world we're surrounded by humans who learn everything from their experiences with their learning capabilities. And we have computers or machines which work on our instructions. Uh, but can machine also learn from experiences and or past data like human being does? So you understand that for you to learn something, um, for you like to learn you either learn something from your past experience or maybe like maybe reading something. Maybe you read something and maybe you get to know about it. But now we have machines. In the last lectures, we have been given machines like instruction to to execute. So you notice that you were just giving you were just like writing some codes and then we ran them, and that was it. So we are just simply asking ourselves, can machines like learn from maybe from data? For instance, in human being, we learn through maybe reading books. You can read journals. Uh, you can watch videos and so on. So in machine learning, I have a good picture here of a human saying that I can learn everything automatically from experiences. Uh, and that question is posed to a machine. Uh, yeah, I think now, yes, the machine says that yes, I can learn from past data with the help of ML. So machine learning is uh, is just a gateway for machines to learn. And I think by the end of this introduction, we will have learned how they achieve that. Uh, Let me just Yeah, so we are saying that machine learning is a subset of AI or artificial intelligence. I think most of you have heard of artificial intelligence, and we are saying it is a subset of AI that focuses primarily on the creation of algorithms that enable computers to learn independently, independently learn from data and the previous experiences. Uh, so there is this guy that is called Arthur Samuel. He first used the machine learning in 1959. Um, so just to sum up, we can say it could be we can just say that without being without like machine being like explicitly programmed, machine learning enables machine learning to automatically run from data and improve performance from the experiences and even predict things. So machine learning algorithms create a mathematical model without being like explicitly programmed. And when I talk of creating mathematical models without like being explicitly programmed, uh, like if we were to program a machine like to predict something, you notice that uh, it will like never learn if at all we don't have these models. It will never learn. It will always like have that predefined output. Whatever like you program is what uh, whatever you program is actually what you will get as an output. But now when now models the machine learning models comes into play, you will realize that you can just pass data to a model. That model learns just like human being, and then even later on maybe you can ask maybe you can ask the models maybe to maybe even predict something it will do just as human. Maybe human can easily predict things because maybe from past experiences. Uh, you can have an example of maybe like maybe in a class of 40, a teacher can always predict maybe someone's whatever. So someone result based on whatever maybe on exercises that the results of exercises that he has been giving or to the student and their performance. So just now from the output of or the results of maybe exercises that have been given in class, a teacher can predict maybe can predict maybe the grade which you are likely to get maybe in the head or maybe term exam. Uh, so, but now when it comes to machine learning algorithms, you just have like to pass data. You pass data, the machine will like learn from those data. Like we'll see some examples. You pass data, then you train. You see how you're going to train those models, and later on maybe you can ask that trained model to predict something for you. Uh, Let us just uh, see these. We are talking of algorithms that can learn from historical data, are either constructed or utilized in machine learning. So the performance will rise a proportion to the quality of information we provide. Um, we are talking of machine learning can learn if it can gain more data to improve its performance. So the more data you pass into the models, the more the model will learn, and therefore in return maybe you expect even the model to perform well after maybe you post some, or even if maybe you try to do a prediction. So let us just see how these uh, this machine uh, this machine learning works. If you can just try to reduce that. Um, I'll start with an analogy here. Like we say, let's say we have a complex problem in which we need to make predictions. So instead of writing a code, we just need to feed the data to a generic algorithm which builds the logic based on the data and predict the output. So you're saying our perspective on the issue has changed as a result of machine learning. So the machine learning algorithms operation is depicted in the following diagram here, the diagram that I'll just show you here, whereby we have input, the past data, you pass into machine learning algorithm. The machine algorithm will learn from that data. It will build some logical models, and then maybe you can pass new data here after the machine learning algorithm has built these logical models. So let me allow someone to join. So after we have like built these logical models, if we happen to pass new data here, uh, we are just like going to get some output. We are going to get some output. This one will I think we will see this as a test data. We just let's say we are passing maybe pictures of let's say dogs, cats, and maybe another animal. We are just passing that data to to a machine learning algorithm. It will happen just to learn from that data, and then it will just build like some logical models. So if you happen to pass maybe a new data here, maybe of cats, from what this model has learned, it can easily like tell you the data that you have passed is either of a dog or maybe a cat. I'll show you a picture of that as we go on. So that is basically about all about the ML, and I think we can just move forward to features of machine learning. Um, so the first feature of machine learning, we are talking of machine learning uses data to detect various patterns in a given data set. Another feature it is that it can learn from past data and improve automatically. Another feature is that it is a data-driven technology. So without data, we have no machine learning. And we also saying that machine learning is much similar to data mining, as it also deals with a huge amount of data. I don't know how many of us have heard of data mining. It's another good area to check. So those are basically the features of machine learning. It is learn it can detect uh, patterns from a given data set. It can learn from past data. It's a data-driven technology, and also it's quite similar to data mining. Um, I think we can just check some of the needs or the need for machine learning in the current world. And we are saying that the demand of machine learning is rising because it is able to perform tasks that are too complex for a person maybe to directly implement. Uh, so how would like do you how do like a human being deal with maybe a data set that maybe contains millions of records? You notice that uh, you can take so many years maybe to learn to even just like get an understanding of a data set that has more than 1 billion records. But it's quite now it's quite like easy with ML. So we are talking of human are constrained by inability to manually access vast amount of data. That is the first thing. Uh, and as a result, we require computer systems which is which can access a large amount of data. So in machine learning has just come to rescue us from maybe working with working with large, working with large data, or even accessing large amount of data. So we are seeing that by providing them with a large amount of data and allowing them to automatically explore the data, build models, and predict the required output, we can train machine learning algorithms. Um, so we are seeing the cost function can be used to determine the amount of data and the machine algorithm performance. So I think we will see that uh, we'll see that you can take note of cost function. I think we will see what is cost function. Um, we are saying we can save both time and money by using ML. That's true. Because if you were to maybe give a human being uh, a large data set, maybe give a machine learning give a machine learning model the same data set, you realize that uh, the machine learning model will take less time to even explore the data compared to human being. And therefore we have various fields where we are using this machine learning. Maybe most of us, if not all, have heard of something called self-driving vehicles. I don't know, but in Kenya we don't have one. These things are just happening uh, outside, even it is outside Africa, but they exist. These self-driving vehicles. Um, we have something like digital misrepresentation identification. I think this one exists, but I don't know if it is. I don't know if it is used in some of the offices Kenya, whereby you can maybe have you can place your face in front of a camera and it recognizes you. I think most of the most of the technology that is used here in Kenya is the biometric tech, where you have just to maybe get identified by use of fingerprints. But uh, with face, I don't know. I haven't come across such tech used. We have also the companion idea by Facebook. I don't know how many of us have heard of the companion idea by Facebook. Any one of us? Any person who have an idea of a companion idea in Facebook? Or who can tell us what is that? Yeah, companion idea. Anyone who knows what is that? No one? These are some. These are just but some of uh, some of the technologies that are used by these social media platforms to even like predict price of a something. Maybe let's say you like in the marketplace, you notice that it is a new feature in Facebook. Uh, so now the companion idea by Facebook is simply use of these machine learning algorithms to like to predict to predict the cost or the price of a commodity that maybe you have posted, for example, in marketplace. So after maybe uploading some pictures and some stuff and some information, it will just like it can predict the price based on the based on maybe on the prices of such commodity or the commodities that have been posted previously. Um, so that is all about the companion idea. You just try to predict the price of a commodity that you want to post in the marketplace. Um, we are talking of different also or that these top organizations such as Netflix and Amazon. They have also constructed AI models that are utilizing an immense measure of information to examine the client interest, even suggest items likewise. So you realize that I don't know most of us if you get into these platforms. Um, in the first place, how many of us have Netflix installed in the earphones? Any person who have installed Netflix? I think I have Netflix installed.
I have.
Yes, also Sharon has. Um, I know most of us like movies. So, Sharon, what do you think these Netflix people like the criteria they use to even suggest movies that you are likely maybe to watch? Are the movies that you would love to watch?
Mm-hmm. Probably it's all about what we are learning today, since it's also an AI generated system.
Yeah, sure. From from these algorithms, you notice that uh, if you get to Netflix, although they changed these uh, initially when you installed Netflix in your phone, you could watch movies free of charge, but only like specified movies. So after having that option for many years, these guys they just use these AI models to even learn what movies or uh, which movies most people love watching. They even went further to a specific individual, like if it is Sharon, maybe uh, they, they could learn what kind of movies Sharon love watching. So after training their model on that, uh, they changed they removed that option for even free movies. But even after removing uh, that that option for free movies, you notice that if today you happen just to to maybe log in that Netflix app, you happen that the movies that you are watching, or the categories of movies that you are watching, they are likely just to pop up. But this time you have to do a subscription to watch them. Any movie that is just uploaded in the Netflix, it will be categorized, and it happens that since they had learned the kind of movie that you guys love watching, those anytime that a movie is uploaded, it will be categorized into categories, and then it will just pop up on your phone based on the categories of movies that you love watching. Also, that is the same case that happens with Amazon. So, and how they are achieving this is through these AI models. They just feed them data, and then they happen to learn to even levels of like being able to predict something. Um, Let us just check the key point which shows importance of machine learning. And one of the key important is we have the rapid increment in the data production. Notice that most of us have embraced this technology thing, the tech thing. Most of us we are posting a lot of data to these social media platforms. And now uh, these kind of data, we really need these ML models to like even uh, extract some meaningful insights from this data. So we have another importance like solving complex problems which are difficult for a human. Uh, for instance, let's say that Netflix is worldwide is having like 40 million users. If you gave the work of categorizing like movies that are uploaded every day to a human being, and even suggest suggest those movies uh, to to people who are using Netflix, you notice that maybe human being could collapse that day, because one thing you are dealing with uh, a large data set, and even now using the maybe the use of what use of maybe based on maybe some rules to suggest those movies to each and every user of Netflix. You notice that you notice by that that human could corrupt that day or even that minute, having assigned um, such tasks to human. But these are some of the tasks, despite the fact that they are complex problem, models will just be able to work through those tasks uh, with much ease. So the other thing is decision making in various sectors, including finance. That is another sector that is largely depending on these models. Um, we have another importance of finding hidden pattern and extracting useful information from the data. Um, Here in Kenya, we are yet to reach this point where we utilize we utilizing these model to extract useful information from data. Most of us are still reluctant to the fact that machine learning exists. So those are just but a few importance of machine learning, and I think from the importance of machine learning, we can go to classifications of machine learning. And machine learning is classified into three types. And the three types are supervised learning, we have unsupervised learning, and also we have reinforcement learning. Uh, with supervised learning, you have to label your data. You see what is that. You have also semi-supervised learning, but machine learning is categorized into three large large classes. But in between supervised learning and unsupervised learning, we have also semi-supervised learning. So with unsupervised learning, we don't give we don't even uh, give or label our data. We'll see what I mean by labeling of data. Uh, Reinforcement learning. This one is quite different from supervised and unsupervised. Um, because with the reinforcement learning, we use our words. We just use our words. I think we just happen to see that. This is basically the classification that is supervised, reinforced, and unsupervised. We can start our discussion with supervised learning. And we are saying is supervised learning sample labeled data are provided to the machine learning system for training, and the system then predicts the output based on what what it has learned from the data. So we are saying that the system will basically use the labeled data to build model that understand the data set, the data set. So after training and processing and learn, we test the model with the sample data to see if it can accurately predict the output. Um, the mapping of the input data to the output data is the objective of supervised learning. We'll see an example. And we're saying that the managed learning depends on oversight, and it is equivalent to when the study learns things in the management of the educator. So we have, in this case, we have like spam filtering is an example of supervised learning. So I don't know how many of us have all notices that whenever like you get a spam email, it will go to the spam uh, folder, and whenever you get like a legit email, it will go to inbox. So the criteria that is used now to determine whether an email is a spam or it is a legit email. This is kind of this is this is a this is an example of again of a supervised learning. Notice that uh, emailing is an area again that has a lot of data. Each and every day, like you have to send email, you have to receive emails, and therefore from all that data, we happen to come with a supervised learning model to categorize those emails, whether they are spams or legit emails. So let us see an example of, let me just show you an example of supervised. I don't know if you guys are able to see this image. You can try to, yeah. I'm hoping that you guys are able to see this. Uh, as I said, that the first step to supervised learning is you must pass in you must pass in data. And in this case, the data that we are passing in here, we have labeled data. So it happens that we are just passing the data of the pictures of cow, we have elephant, and then we have the camel. So that is the kind of data that we are passing here. These are just but labels. So you notice that here I'll just pass this data. And it happens that this data it is labeled. This one is a camel. Camel just looks like this. An elephant looks like this. A cow looks like this. All these kind of data, I'll just pass it to my algorithm here. In this case, it's a model, right? So what happens here in the algorithm? We are going to like to have our model here uh, train train on this data. We'll be able like to tell this is we have cows and the elephants and the camel images like passed in this model here. So it will just train and even save what it has like what it has learned, just like human being. You notice that a kid of maybe a 1 year old kid doesn't know what is a cow, or he cannot even say what is an L. cannot like tell this is an elephant or this is a camel. So like the process now that takes that kid to learn, it's also the same. It's also the same process that is now here. That we have a new model here. We just like passing in data, labeled data in this case, telling it that this is a cow, this is this is an image of an elephant, this is an image of a camel. Then we just happen to pass it. So after now the algorithm has learned. Uh, you notice now here is the processing. It will just process. It will just now process, and you notice here that we just like want now to we now just want to test. This is why I was just saying that we are going to pass a new test data. You notice that this data, this whatever data I'm passing here, it doesn't have labels. I'm just passing an image of a cow, an elephant, and a camel. So it will be the work of now these algorithm to tell me the names of these images that I have passed here. You notice that these images don't have labels, but the data that I train my model with has labels. So already the algorithm knows, or it is aware of it has cows, it has elephants, and it has camel. So this is the interesting part. After now I have passed this kind of and labeled data here. The model now will be able like to tell me that this is an elephant, even give its label. This is a camel, so it gives me the label of that, and also the cow. So this is the whole like the whole process for having a uh, supervised supervised model. So any question up to that point? Any question on supervised learning? Any question? Uh, Thumbs up if you are good with supervised learning now. I think most of us have understood what is supervised. Good. That is quite a good number. So I think we can just move to the second classification. But before we move to the second classification, we are saying that supervised learning can be grouped further into two categories. And the first category is the classification, like the one we had of categorizing images into cows, into camel, into what, and into elephant. So I think just to yeah, I think we can have that. So we are saying that classifications involves predicting a categorical output variable or a class label. I think we have already seen that. That was a good example classification. And we are saying that the goal is to learn a decision boundary that separates different classes in the input space. Examples of classification tasks include the spam detection. We have the image classifications. I think the spam detection I already mentioned that. We have image classification. I think I also said that. And also we have sentiment analysis. Um, I think we can see some of the algorithms that are in this category of that is the classification category. In here we use some models such as logistic regression. We have the k nearest neighbors, we call it the KNN. We have the support vector machine, we call it the SVM. We have decision tree, random forest. We have also another one that is a gradient boosting machine, that is GBM. And we have the best of all, that is called the neural network. We will come to see in each category of like in each category we'll just work with one algorithm because of time. So that is coming next week. That is on Monday we will work on supervised learning. That is on Tuesday, and supervised. Wednesday we will have reinforcement learning. So in each classification we will have one algorithm. We create an algorithm and even test that. So the other category of supervised learning is the regression. And in regression, this involves predicting a continuous output. And the best example of this is predicting house prices based on various what? Based on various um, based on various maybe um, maybe based on the variables, the input variables. And to determine the house price, there are so many factors to consider, like the location, like the social amenities in the area, also the geographical location of where the house is built. There is so much factors to consider while determining these the house prices, also the stock price, and even the temperature. So now predicting these, we use regression models. I think we will in here we will work with house prices. We will work with house prices and see how it works. So those are the basically the two subcategories of supervised learning, that is classification and regression. Um, some of the algorithms that are used in the regression include we have the linear regression, we have algorithms such as polynomial regression, we have ridge regression, we have lasso regression, support vector regression, we have also decision tree regression, random forest regression, and also the gradient boosting regression. So these are some of the algorithms that you can check on your own time. if at all you really need to be a machine learning engineer, so you must be aware of all these algorithms. Let us just move to the second classification of ML, that is unsupervised learning. And unsupervised learning is a learning method in which machines learns without supervision. And by supervisions, I mean in here we don't pass labels. That is what I mean by without any supervision. So we're saying that the training is provided to the machine with a set of data that has not been labeled or classified or categorized, and it will be now the work of the algorithm to act on that data. So the goal here of the unsupervised learning is to restructure the input data into few features or groups of objects with similar patterns. So it's like just the previous example now. We pass, we pass, we pass cows, we pass pictures of camel, we pass pictures of elephant without labels. And then now it is the work of that model or that algorithm now to determine that these all images are for cow category, and all these images are for camel category, and so on. Let us just see some what an example here of unsupervised learning. So in here we are just passing some images. That is the images of an elephant, but there we have images of camel, we have images of cows. But you notice now this time we are not passing in the labels. So we just pass that uh, into our algorithm here. So it will just become as a raw data, data without like any meaning, if I say so, or unknown data input. In here we are saying that it is we have an unknown output, and no training data set. So in here we just pass in the data. So in the algorithm, it is just like try to classify these the like images. If it is the images of elephant, if we happen maybe to pass over 100,000 images of elephant, it will just pick one. Also, the same applies with camel. The other applies with cow. It will just pick one image out of all the similar images or common images. So after now processing that, you realize that the output here we are getting the classifications of elephant. We have the classifications of camel. We have the classifications of a cow. So that is unsupervised learning. It has also some subcategories. I think you can check on that. We are talking of in unsupervised learning. We don't have the predetermined results. The machine tries to find useful insight from the huge amount of data. And we are saying that it can be further classified into two categories. That is, the first category is clustering, and we all know what is clustering. And clustering involves grouping similar data points together based on the same similarity or distance measure. The goal here is to discover inherent grouping or clusters in the data without the prior knowledge of class labels. That is basically what clustering is. You just happen to you're grouping objects with the same characteristics together. So that is what we call clustering. And we are saying that the goal here is to discover the inherent maybe groupings or clusters. And now from the data that we have first in our model, in here we have, or even we can just see before we go to the algorithms used, we can see some examples of application here, whereby we have customer segmentation, we have document clustering, we have image segmentation. So with customer segmentation, you can maybe if you had data that contains maybe customers information, you can group customers into various groups. You can group them based on whatever they buy. Customers that buy pizzas on Tuesday, customers that buy meat pie on Tuesday, customers that buy other product on various days. So you can cluster those customers based on whatever they buy from your shop. Also, we have the document clustering. Also, the same concept. You just classify document based on their characteristics. And we have also image segmentation. Uh, with image segmentation, you can like if you are given an image of maybe face image, you can segment that image, and since the image has different components, it has eyes, it has nose, it has mouth, ears, so you can segment that image into, or divide that image into some components. In here we have I think I just listed two algorithms. That is the k-means clustering, and we have the next one, we call the hierarchy. I don't know how you mention that clustering, but we have so many other algorithms to again that are used in clustering. I think you can still check that, but these are the two main that are mostly used. The next classifications is association, and the association rule learning identifies interest in the relationships or associations among variables in large data sets. The goal here is to discover frequent patterns, associations, correlations among items or variables. In here we can have some examples also, such as That is the market basket analysis. So you realize that in the e-commerce platforms, we have okay, after selecting an item from an e-commerce platform, where is it inserted? Okay, let's say, like, for example, you get into Jumia. After selecting items that you would wish maybe to buy, where are they where are they added? Any person?
Um, for example, when you shop, I think in the Jumia database,
Mhm.
plus there is that option of cart.
Yeah,
It's called the CART, where when you shop, I think that's the database, yeah, Jumia. So yeah.
yeah, that is exactly what I'm looking for. Like, when you select an item, it basically like it will like be added into a cart. So you notice that in that site, most people visit that site, and you notice anytime that you get into that site, even if you are not buying any item that you select, it will be added into a cart. So that is data. So whatever you are inputting into that cart is data, and it can be analyzed, because the cart now will contain some of the items that maybe you wanted to buy, or even uh, items that you check to buy. So in here you can do that analysis here of those cards, and even come up with a pattern that uh, these people, whenever you get into a cart, whenever you get into that e-commerce platform, there is this item maybe that is bought frequent. Uh, so you can easily like now do the analysis of those cards, and even come up with patterns. With a pattern, you notice that uh, it's quite difficult to to buy some things and leave out others. So that is the pattern that we're always looking for in those market basket analysis. That is, in this case, we're using a cart. Uh, we also have a recommendation systems again, and also anomaly detection. This normally happens in networks, but recommendation system, I don't have a good example with the recommendation system, but with the anomaly detection, this mostly happens with networks, where you just like uh, check maybe uh, and even systems, even this system, banking center. How are you able like to check anomaly? You can easily detect fraud activity. So these are kind of algorithms that are used here. We have the a priori. It's called the a priori algorithm. We have also the frequent pattern growth. These are some of interesting algorithms again to check. Even you can apply them to come up with you can come up with even a recommendation system or even come up with a cart or market basket analysis. Um, I think we have talked much on that, and I would like to get to our last part of our discussion today. As I had said, I don't want like to take much of your time. I know it's already we get approaching. I wouldn't like to do an implementation of this algorithm at the moment. So just an overview of what they are and what they do, and even get to understand the kind of algorithms that are used in each classification. So I think we can get into the last classification, that is reinforcement learning. Let us just see what reinforcement learning is, and I have this definition here. Of reinforcement learning. I'm saying that reinforcement learning is a feedback-based machine learning technique in which an agent learns to behave in an environment by performing the action and seeing the result of the action. Um, for each good action, the agent gets a positive feedback, and for each bad action, the agent gets negative feedback or a penalty. So I'm like, I know most of us are wondering how does this happen? Does even this exist? It does. So let us just see the definition here. Then maybe I can give an example of this. So I'm talking of reinforcement learning. It's a type of machine learning method where an intelligent agent or a computer program interacts with the environment and learns to act within that. So I would like maybe to give an example of a child. A child maybe that is, let's say, 1 year. Yeah, 1 year. Let me just say a child of 1 year. And you happen like to leave this child in a kitchen. Kitchen is our environment in this case, and the child is the agent that I'm referring to as a computer program. So in this kitchen, of course, the kitchen must have that maybe using firewood or maybe gas. So in maybe you happen maybe to leave the kitchen, maybe you leave the one I understand that 1 year kid is uh, like who are to leave. The child has to keep moving from this place to the next place. So it happens that now maybe let's say that there were the fire in place or the motor in place. That is either gas or the firewood. So maybe when that kid tries to approach or even maybe to stretch hands towards the source of fire, and maybe the child gets like burnt simply because he doesn't know that that is fire, and it can easily burn him or her. So whenever she or he stretches that hand towards the direction of the fire, you notice that she or he might get burned, and you know the reaction. The first reaction it will to remove the heart from the source. So don't think that is now registered into his head that whenever he get into to kitchen and maybe try to stretch hearts towards that fire again, he might get burned. He might not land uh, by the first instance, but if it happens that next time he or she is probably like to be more uh, careful with stretching hearts towards that direction. So it's just is that analogy like it's a it's a it's a it's a it's a pure it's a good example when it comes to reinforcement learning. You just get introduced to you introduce a computer program into a new environment, and then it will learn from that environment. So it happens that in this in our analogy here that the kid will have registered a negative what is it it will be he will have registered a negative result, and that whenever it has this fire, it might get burned. So in this case now we are trained to in this analogy or in this I mean reinforcement learning. So for for positive for a good action, you notice that the child stretching hard to the fire is a bad action. So with the reinforcement learning, we are going to reward that that action a negative feedback, or what we call a penalty. But if it was for maybe a good action, maybe that child did, we could have given a positive response or a, a positive feedback towards that uh, action. So another example is of maybe a robot in a maze that maybe a robot that is trying to. I have an example here. Suppose there is an AI agent present within a maze environment, and his goal is to find a diamond. So you realize that the agent will interact with the environment by performing some actions. And since it doesn't have, let's say, any knowledge about the environment, it might conduct it might conduct a good action or a bad action. So we are going to reward those actions by a good reward by either by the we can give a penalty, or maybe we can give a good reward. So we are saying the agent interacts with the environment by performing some actions, and based on those actions, the state of the agent gets changed, and it also receives a reward or a penalty as a feedback. So let even have that diagrammatic representation of that. So it does this agent does action to this environment, and what it does it's a reward. It gets a reward or a penalty. You realize that if it is a robot and it is moving towards towards what? Towards the wall. It will get it will get like it will get hit, and that is a bad that is a bad what? That is a bad action. Therefore, it will receive a penalty. So the robot getting like when the robot like come into contact with that what that wall, it will get hit. That is a penalty. So if it was like a human being, you will you get what as a result, you will get hit, maybe umie kidogo, and that is the kind of reward that you are getting. In this case, a negative one. Um, in reinforcement learning, you notice that we are having some terms such as agent, we have environment, we have action, we have state, reward, and I didn't mention of policy, but we see that. So it's good again, like to learn what does this term means. Um, for instance, an agent. This is an entity that can perceive or explore the environment and act upon it. I just gave you an example of a robot. A robot that is placed in an environment. So in this case, a robot will be able to perceive or explore the environment and act upon it. The environment is a situation in which an agent is present or surrounded by, and in reinforcement learning, we assume the stochastic environment, which means it is random in nature. Um, that is environment. It's kind of a situation, like the situation we placed the robot in, like the situation of trying to get the diamond that it is in a maze. So it's an environment is a situation. Uh, Let us just get to actions. These are the moves. Uh, these are the moves that are taken by the agent whenever it is placed in a certain environment. We have another term that is called the state. The state is a situation returned by the environment after each action. So if you move to, if you happen, I think you know what is a maze. Who of us knows what is a maze? Do you guys know what is a maze? I'm assuming that most of us knows what is a maze. So each and every time, like you make a step, a step in this case is the action in that environment. You're going to you are no longer going to be in the initial position. So you will be in a new position. That is what I'm calling state. you moving from one place to another in the environment that you are given. That is what I'm calling a state. There is this reward. Reward is a feedback returned to the agent from the environment to evaluate the action of the agent. Um, the other term is the policy, and a policy is a strategy that is applied by agent for the next action on the current state. I think I can give another example here of a policy. Who who knows how to play this game? Why am I forgetting this game? There is this game that why am I forgetting this game? Okay, maybe I remember the process. But we are talking of these are just is a strategy that is applied by agent to the next to like to that is applied by agent for the next action based on the current state. I'm forgetting this game. There is this game that is okay. Maybe I remember. I tell you, I think you will be able to relate. There is another term that is called value, and it is expected long-term long-term return with the discount factor and opposite to the short-term reward. I think I don't have to explain much on the value. Then we have something that we call key value. It is mostly like similar to value, but it takes one additional parameter as the current action. Okay. You're going to get all these. We're going to have an implementation of all these. So you shouldn't worry where to use this. Let us see the approaches to implement reinforcement learning. And by the way, reinforcement learning is one of it is one of the complex form of machine learning. This one is quite complex. Approaches to implement reinforcement learning. We are talking of there are mainly three ways to implement reinforcement learning. We have the value-based, and in the value-based approach, it is about to find the optimal value function, which is the maximum value at a certain state under any policy. So it's kind of you are trying to get the maximum value in a certain state, and at any policy. So therefore, the agent expect a long-term return in any state and policy. I don't have to elaborate. I think this one is with an example we are going to understand that better. So we have also policy based. In this case, now we have in this case the goal here is to find the optimal policy for the maximum future reward without using the without using a value. But in this case, value based, we must use some values. But with policy, we don't have we're using we don't use a value here. So in this approach, you are saying that the agent tries to apply such a policy that the action performed steps helps to maximize the future reward. So here, the key thing uh, is to achieve to achieve the maximum future reward without using a value. But now here we are using policies. The policy-based approach has mainly two types of policy. That is deterministic and stochastic. Determinism is the same action is produced by policy that is pi at any state. We are going to see what pi means. We're going to see what pi means just right now. We have these stochastic in this policy. Um, Probability determines the produced action. Here the probability will produce will determine the produced action. And the third way to implement this reinforcement learning is model based. And we are saying in the model based approach, a virtual model is created for the environment, and the agent explores that environment to learn it. And there is no particular solution or algorithm for this approach because the model representation is different for each environment. So that is the model based. We can just quickly check the elements of reinforcement learning, whereby there are four main elements of reinforcement learning, and that is the policy, signal, value, function, and um, model of the environment. So these are things that you can easily check. Let us just go through the policy. And we are saying that a policy can be defined as a way how an agent behaves at a given time. So it maps the perceived state of the environment to the action taken on those states. So a policy is the core element of reinforcement learning, as it alone can define the behavior of the agent. So we are saying that in some cases it may be simple function or a lookup table. Whereas the other cases it may involve general computation as such process. So it could be deterministic or stochastic policy, as we had said. So let us just check for deterministic policy. We are just having action represented by A is equals to the pi, and that pi just represents the stochastic policy, where A is the action and S is the state. But in this deterministic, we are just using the state. Action is equals to pi. Then we have that multiplied by the state. For stochastic here, we have an equation here. I just want to break down the notations for the equation. So I have pi into bracket uh, a then we have that that whatever. How do we call this? This sign. It's a sign that, but I'm forgetting this name for it. Uh, so these represent the stochastic policy, and we are told here the A is an action and S is a state. The other one we have P, and then we have squared bracket at A is equals to at is equals to A, and state is equals to S, represents the probability of taking an action A at a certain time, and given that the agent is in the state. So yeah, in simpler terms, we are saying that the stochastic policy, that is this, describe the agent strategy for selecting an action based on the current state. I think you can take this example of a person who want maybe to do to carry out a certain task, and this task happens to it has a procedure to do it. Not even a procedure, but it has so many steps to do it. So at every step you have to decide the next step. It is just the same case with this formula here. So at a certain stage you have to choose the action to take. So it defines the likelihood of choosing each action given that the state of the agent is in, uh, allowing for probabilistic decision making in the reinforcement learning task. I'm quite sure that these terms are not new to you because most of us, I believe, we have done we have done or we are doing statistics, and these terms are quite familiar with most of us. So this stochasticity allows the agent to explore different actions and learn optimal behavior over time through the interaction with the environment. That is all about the policy. We can go to the reward signal, and the goal of reinforcement learning is defined by a reward signal. At each stage, the environment sends an immediate signal to the learning agent, and this signal is known as the reward signal. So anytime that you want to do a certain action, there is this reward signal that you get, and the goal here is to get the highest reward signal. So you might be moving to a certain direction, maybe you are getting 10%, you are moving to another direction, you are getting 50%, and you're moving to another direction that you're getting maybe 70%, and another you're getting 80%. So that is the reward signal that you are getting here now. So by getting those reward signal, you're going to determine the path that you are going to follow. In this case, the path with the highest reward. Um, we are talking of these rewards are given according to the good or bad action taken by the agent. I think you already know that objective is to maximize the total number of reward for good actions. I think I've already said that. So let us come to the value function. And the value functions give information about how good the situation and the action are and how much reward an agent can expect. I think all these I have explained. That a reward indicates the immediate signal for each good and a bad action, whereas a value function specify the good state and action for the future. I think these are just simple things to follow. I'll share with you the notes so that again you can go through them. And the last one is the model. And the last element of reinforcement learning is the model, which mimics the behavior of an environment. With the help of the model, one can make inferences about how the environment will behave, such as if a state and action are given, then the model can predict the next state and reward. So the model is used for planning, which means it provides a way to make uh, the way to take a course of action by considering all the future situation based before actually experiencing those situations. The approach for solving the reinforcement learning problem with the help of the model are termed as a model-based approach, and this is the kind of approach we are going to look at. Comparatively, an approach without using a model is called model-free approach. Um, I think that happens to be our head of discussion today. And I think by now most of us now knows what machine learning is. I know the reinforcement learning has a lot of things to to cover, but I'm hoping after maybe going through these notes again, we have a grasp of maybe some concepts before even we get into coding. All whatever we have done here, we are going to implement it in coding. That is the from supervised to reinforcement learning. Yeah. In each case, you are going to have a model at least trying to illustrate that. I know that was much to cover in some few minutes, but I'm hoping at least most of us now have an understanding of what machine learning is, right? Do we have any question? Any question on or maybe a clarification on what we have just checked? Faiza, Adams, any question? Or maybe
No, I'm good. Yeah.
Aiga? So Aiga is good. The machine learning is not for the faint-hearted, by the way. It has a lot of things to cover. But anyway, that is it. That is all about machine learning. So the next week for the 3 days we're going to have lectures. I will have now to implement all those forms of machine learning. So by tomorrow you expect the week 3 assignment. You know, most of us are thinking that I have forgotten, but I haven't forgotten that. And you must have a week 3 assignment, and that is going to cover what you were doing yesterday. So if you did go through what you were doing yesterday, you must be lagging behind. So you must check what you were doing yesterday. We have a whole project on that, the ADA process. Um, I just want to thank you guys. Just want to thank you for following that, and I'm hoping that by the end of next week, you guys will have a lot of information about even machine learning. You will have grasped a lot of information. So I think we are just going to drop off and wait for the assignment. With the assignment, as I had said, I don't want to take much of your time. At least I had promised you to finish at 8, but I can see it's already 20 minutes past. So if we don't have any question, then I think we'll just have to drop off. Are we good with that? And I wish you guys a good weekend. Also remember to submit your assignment on time. Haya, kwaherini, tupatane on Monday.